Okay, this is part 2 of Utah Middle School Math Project 1.1F, creating and solving linear equations. We're doing this warm-up to get started, so pause the recording until you've had a chance to complete this. And now we're continuing on to see how this should have been done. Remember, this is an equation which is made up of an expression, which is simplified, equal to another expression, this one, is not simplified. So before I try and solve, it is best if I simplify first. When I simplify, I'm going to start by changing all of the subtraction to adding a negative. So 3 minus 5 groups of 3x plus 1 becomes 3 plus a negative 5 groups of 3x plus 1. Now that I've changed subtraction to adding a negative, I cannot combine the terms that are in the group. So that means the grouping symbol must be there for another reason. No exponents, and then I make it to multiplication so I can see why those grouping symbols are there. So I need to do the distribution first. Not just 5, but negative 5 groups of 3x, or the opposite of 5 groups of 3x means I have negative 15x. And, again, not just 5 groups of 1, but the opposite of 5 groups of 1. So, negative 5 times 1 is negative 5. And now we can bring down the 3 unit tiles plus those groups that have now been taken out of the groups. And now I can combine like terms where I have 3 positive unit tiles, 5 negative unit tiles. We're going to have a couple of 0 pairs, and that's going to leave me with 58 is equal to negative 15x minus 2. Again, 3 plus a negative 5 ends up being plus a negative 2 or minus 2. Notice that I'm hoping that you are also getting comfortable with your subtraction and adding a negative. Yes, I could have and should have written it plus a negative 2, but then my next step would be changing that adding a negative back into subtraction because we're at the solving equation stage. So from here, I'm going to undo the subtraction by adding 2. Negative 2 and positive 2 zero out. That's the whole point of choosing to add 2 is to make that be a 0. 58 plus 2 is 60, and 60 is equal to negative 15x. So my final step, we're going to divide each side by a negative 15. Negative 15 divided by negative 15 ends up being just 1. So that's why I have one single x, or in other words, x is alone. 1x is equal to 60 divided by a negative 15 is a negative 4. So negative 4 is equal to x, or x equals negative 4. Talk with your groups because there are enough incorrect answers. Will you talk with your groups about the mistakes that were made? Here are those mistakes. You can try and do some error analysis. Pause the recording as you discuss. Okay, we're back to 1.1F. I should have deleted those slides. 1.1F. That's where we're going to pick up. Make sure you have that out. Okay, so again, what we're doing in 1.1F as we prepare for our test, we are now writing our own equations from stories. And then once we write those equations, then we can solve them. This is one of those money riddles. I kind of want to be this crazy uncle once my own nieces and nephews are old enough. I want to be a crazy Uncle Hank that will give money if they can solve math equations. My nieces and nephews aren't quite to that age yet. So, Uncle Hank tells his nephews, I have twice as many dimes as quarters. I have 12 more nickels than quarters. I have $4.60 total. Whoever can solve my riddle will get my coins, and Owen has a good start to his equation. But remember how I told you this is the key to success. If you take a second and write down small little expressions, it makes it a lot easier to tie them all in together to create a big, long equation. So let's break this up. It looks like he has dimes, quarters, and nickels. So let's write down what it's going to be for his dimes, his quarters, and his nickels. I have twice as many dimes as quarters. I have 12 more nickels than quarters. How are we going to represent all of this information? So start by talking with your groups. quarters, dimes, nickels. Just write little miniature expressions to represent what we have here, and then we can tie it all in together to this equation that Owen has started. Pausing the recording as students discuss. Okay, how am I going to represent the number of quarters that he has? Sam? Yeah, Q for quarters. Exactly. How am I going to represent the number of dimes that he has? Emery? 2Q, because he has twice as many dimes as quarters. And nickels, how am I going to represent that? This is a tough one. This is where a lot of students make a mistake. Is it 12Q? No. How do I represent this, Peyton? It is, because it's the number of quarters. 12 more than that is plus 12. And now with that in mind, now we can fill in the blanks. What in the world does 0.25Q actually represent? Based on the fact that quarters is Q, what does 0.25Q represent? Yes, Daxton. Not really. So again, let's think about what Q means. Q is how many quarters. So what does that 0.25 times Q actually represent, Tage? Yeah, how much all of the quarters are worth. So if quarters, this is how many he has, quarters are 0.25, a quarter of a dollar. So this is going to represent the money in quarters. How much money he has in quarters. All right, and here I have the 2Q. Thanks to the work that we already did over here, dimes is 2 times Q. So we know 2Q goes here. But what goes in this blank spot? Using this as our guide, 0.25Q, this is the value of a quarter times how many quarters. This is how many dimes we have. So what should go in that blank spot prior to that? Not enough hands. Go talk with your groups. Okay, and now come back to me. What goes in this blank spot? If 2Q represents how many dimes we have, what goes in the blank spot? Timothy. Say that again. 12. Why 12? It would be Q plus 12, but take a look. We're not talking about the nickels. What are we talking about? 2Q represents how many dimes? Let's go back to the beginning here. If 0.25Q represents how much money we have in quarters, because we're taking the number of quarters that we have and multiplying it by the value of a quarter, which I hope you know is 0.25. I now have 2Q. This 2Q represents how many dimes I have. So how many dimes I have? Yes, Emery? Why? That's how much a dime is worth. The number of dimes times the amount, or what a dime is worth, the value of a dime. The value of a dime times the number of dimes, this is going to represent the money in dimes. That was pretty rough. Will you please go back and discuss with your group what needs to go in this final blank spot? We have 0.05 and a blank. What needs to go here? Talk with your groups. Ready, set, go. And now voice is off. Please come back to me. What needs to go in this blank spot here? Not enough hands. I think that those with hands up are probably going to earn some more coins because they're actively engaged in this problem. Oh no, it's too late. Sorry, your hands weren't up. No coins for you. Gabe. Yes, Q plus 12 in parentheses. Why is it Q plus 12 in parentheses? Yes, this is how many nickels we have. What is the value of a nickel? 0.05. Be careful. There is a future problem, and students often write this down. What would this have to represent? If it was 0.5, what would that represent? A 50-cent piece, a half dollar. That is very different than 0.05, only 5 cents. Okay, and now that we have written this equation, now it is time to solve it. So we can answer how many quarters, how many dimes, and how many nickels Uncle Hank has. Let's solve this. 0.25Q. But now, for my next step, I need to simplify 0.1 times 2. 0.1 times 2q. That simplifies 2. I'll wait. I'll just keep on waiting because y'all have calculators. So even if you can't do it in your head, like I just did, you have calculators. 0.1 times 2q. Still not enough hands. We have calculators, which means either your hand is up because you know, or your hand is busy typing it into your calculator. Thank you. Hayden. Yes. 0.2 or 0.20 if you want to be consistent and show to the hundredths place. 0.2q. Just don't forget about that q at the end. And now 0.05 groups of q plus 12. So 0.05 q. And 0.05 times 12. Again, you have calculators. If you don't already know, you should be typing it into your calculator. Thank you so much. Porter. Yes, 0.6 or 0.60 if we're looking to be consistent and keep everything to the hundredths place. And all of that is equal to $4.60. So all I did is I took care of the multiplication part. Now it's combined like terms. All you can see is addition left in this. 0.25q plus 0.20q plus 0.05q all ends up equaling 0.50q. Plus 0.60. I just combined these like terms, right? And all of that is equal to $4.60. Now, we cannot combine q's with non-q's. They are not like terms. So now it's solving time. We subtract 0.60. And that leaves me with 0.50q is equal to, yes, 460 minus 60 cents is equal to $4. Again, keeping my 2 decimal places, keeping everything consistent to the hundredths place or to the nearest penny. And now we undo multiplying q by 0.50 by dividing by 0.50. And I'll wait until I see hands. $4 divided by 0.50. How many half dollars fit into $4? Brock. Try again. Watch your decimals when you're typing it into your calculator. 4.00 divided by 0.50 q is equal to 8. So how many quarters does Uncle Hank have? 8 quarters. How many dimes? Remember, the dimes is the number of quarters multiplied by 2. So that means that the number of dimes is 16. And the number of nickels is the number of quarters plus 12 extra. So 8 plus 12 is 20 nickels. You have one like that on your homework, so I hope that you paid attention. You do have one like that on your homework. Let's practice a little bit more before homework time, though. All right. Use the story below about Farmer Ted and his animals to answer the questions that follow. You're going to notice, once again, we have this set up. This is our key to success. Break it down. Weight of a cow, weight of a horse, weight of a sheep, weight of a pig, before you try and write the whole equation connecting them all together. Farmer Ted is weighing his animals. He knows that a pig weighs approximately 1/4 as much as a cow. We already know that a cow is C. Think about what that's going to be for a pig. He also knows that a Clydesdale horse weighs about twice what a cow weighs, and a sheep weighs approximately 100 pounds less than a pig. Take a second, write those expressions. Use the story to write out the expressions. All right, who's ready to share? Weight of a horse. How am I going to represent the weight of a horse as in relation to the weight of a cow? Gracie. Yes, 2C. We read that a Clydesdale horse weighs about twice what a cow weighs, so we take the cow and double it. And weight of a sheep. How am I going to represent the weight of a sheep? Maverick. Okay, good point. Maybe we should skip to a pig first. We'll go to a pig first and then we will go to the sheep, because the sheep weighs approximately 100 pounds less than a pig, so we need to write the pig expression first. So what is that pig expression, Maverick? Exactly. You can say 0.25c, you can keep it a fraction and say 1/4 c. Either way means the same thing. And now we can then relate the sheep. A sheep weighs approximately 100 pounds less than a pig. So here's a pig, 0.25c. 100 pounds less than that is that 0.25c minus 100, just as Maverick said. Okay, so we wrote expressions for each one. So now we can put it all together. Write an expression for the weight of 1 cow, 1 horse, 1 sheep, and 1 pig. Well, 1 cow is going to be C. 1 horse is going to be 2c. 1 sheep is going to be 0.25c minus 100. You can put that in parentheses if you would like to. And the weight of a pig, 0.25c. But that's not what he really has. Farmer Ted puts 3 cows, 2 Clydesdale horses, 4 sheep, and 1 pig on a giant scale used for weighing semi-trucks. The scale reads 7,850 pounds. Approximately, how much does each animal weigh? So we need to adjust this expression because this expression was just for one of each. But we now have 3 cows, 2 Clydesdale horses, 4 sheep, and 1 pig. I'm going to put you guys to work in groups. I want you to write the equation, and I'm going to give you enough time. I also want you to solve it, and we're going to come back just to check answers. So with your groups, find out how much each animal weighs. Ready, set, go. Farmer Ted has 3 cows, but a weight of a cow is C. So I'm representing the weight of just the cows by 3, because there's 3 cows, and timesing it by C, because a cow weighs C. Plus 2 Clydesdale horses, that's 2, multiplied by the weight of a horse, which is 2c. Notice how I'm showing that. 2 groups of 2c. Yes, I know that 2 groups of 2c is 4c, but I'm writing this down exactly as I see it, step by step by step. So when we have 4 sheep, that's 4. The weight of a sheep is 0.25c minus 100. I'm not pre-simplifying it, I'm writing it down exactly as I'm seeing it in the story. And lastly, 1 pig, you could, if you wanted to be really clear, say 1 pig, which is 0.25c. That much I don't need to see, because I know that when it's just 0.25c, I know that that's the same as 1 of those. This is not an equation yet. This is just adding up all of the weights. Now we got to go a step further and say all of those weights is equal to the 7,850 pounds that the scale says. Then we can simplify. 3c plus 2 groups of 2c is 4c, plus 4 groups of 0.25c minus 100 is 1c minus 400, plus 0.25c. All of that equals 7,850. That's just one step in simplifying this portion of the equation. Now we got to simplify the rest. 3c plus 4c plus 1 more c plus 0.25c. I hope you all agree that we have 8.25c minus 400 is equal to 7,850. Solving steps include adding 400 to each side, because minus 400 plus 400 is going to zero out. Balance it, do the same thing the other side. That's how I end up with 8.25c is equal to 8,250. 8.25c is equal to 8,250. I undo the multiplication by dividing each side by 8.25. And I have c is equal to, I'm doing it in my head, but I hope you all agree that a cow weighs 1,000 pounds, right? Okay, so a cow is 1,000 pounds. A Clydesdale horse is twice the weight of a cow. So that Clydesdale horse is 2,000 pounds. A pig is 1/4 of the cow. 1/4 of 1,000 is 250 pounds. and a sheep is 100 pounds less than that. So 250 minus 100 is 150 pounds. All right, I'm not going to continue to guide you through each of these quite so much because this is partly practice for your test. That being said, this next one, I just want to make sense of the notation because it's a little bit weird. So Miley is trying to solve this riddle. The sum of 3 consecutive integers is 84. What are the integers? When we say the sum, what are we talking about first of all? And the clues are already in the problem below. But what are we talking about when I say the sum? Thank you, Emery. Exactly, the answer to an addition problem. So I'm going to be summing or adding 3 consecutive integers. What does consecutive, what does that refer to? Seth, you want to give it a try? Yes, in a row. Consecutive means in a row. And we're referring to integers. I hope you remember from last year what integers are. Integers are whole numbers. They're negative counterparts and 0. For example, if I'm looking at consecutive integers, 3 consecutive integers, and I'm starting with 2, the next integers would be 3 and 4. If I'm starting with 10, the next integers would be 11 and 12. So we could answer this question by just randomly picking 3 integers, adding them, and seeing if they get to 84. But that's going to take a lot of time. The guess and check method is never my favorite. So we can solve this riddle by creating an equation. Notice, we don't know what the first integer is. It's going to be n. But the second integer is going to be n plus 1. Think about why. If we start with 10, then the next integer is going to be 10 plus 1, which is 11. And what would the next integer be? How are we going to represent that? Tage? Nope, because we don't know if it's 11. All we know is that it's n, and then n plus 1. Seth? N plus 2. So if it were 10, it would be 10 plus 2, and 10 plus 2 is 12. That's how we get 10, 11, and 12. So now I don't know what the first integer is, but I know that the one that comes right after is going to be that same integer plus 1. And the one that comes after that is going to be that original integer plus 2. And remember, when I sum those, when I add them up together, it equals 84. So we completed the equation. Now it's up to you to solve that equation. Pausing the recording as you work on that. We're coming back just for the answer. This equation simplifies to 3n plus 3. Which we solve by subtracting 3 from each side. Subtracting 3 zeroes out this positive 3. And I have 3n is equal to 81. We divide each side by 3 and we get n is equal to 27. So again, going back to the original. That means the first integer is 27. The next integer is 27 plus 1, also known as 28. And the third integer is that same 27, but it's 27 plus 2, which is 29. So those 3 consecutive integers are 27, 28, and 29. That notation is also going to be helpful for a future problem, so just make sure that you take notes on that. The next one requires a little bit of knowledge from last year. Let's see what you remember. We have an incomplete story, but we do have expressions this time. So this time we're writing the rest of the story, but we're writing the story based on the expressions that are already written for us. We need to talk about the next one. So you guys can do this one on your own. I'll give 2 minutes, pause the recording, give yourself 2 minutes, and then come back and do it with us. I did not realize how much you had forgotten from last year. In triangle ABC, the measure of angle B is 3 times larger than, we're going to use this information over here, is 3 times larger than the measure of angle A. This M stands for measure of angle A, measure of angle B. And the measure of angle C is 20 degrees less than the measure of angle A. The sum of the angles in a triangle, in case you forgot from last year, when we sum or add these three together, we get 180. So the sum of the angles in a triangle is 180 degrees. What is the measure of each angle in the triangle? Time to solve the equation, which is already written for you. You just had to complete the story. But now x plus 3x plus x minus 20 equals 180. That means I have 3x, 4x, 5x minus 20 equals 180. We solve by adding 20 to each side. So I have 5x is equal to 200. We divide each side by 5, and we get x is equal to 40. No? I did that in my head. Is it 40? Okay. So, what is the measure of each angle? Well, that means A is 40. B is 3 times 40, which is 120. And C is 20 less than 40. 40 minus 20 is 20. And let's just double check. Do they still add up to 180? Yeah. 120 plus 40 is 160 plus 20 more is 180. Now let's talk about number 6. You already had a homework problem like this. Josh works 40 hours a week as a nurse practitioner. He makes time and a half for every hour he works over 40 hours. Josh works 60 hours one week and earns $2,100. Part of the equation that represents his situation is shown. Notice, this is his pay, which is equal to 2,100. We just need to fill in this. So, how many hours total did he work? 60. But the first 40, that's paid at a normal rate. What is his normal rate? Try that again. What is his normal rate? We don't know. So what are we going to use? We could use X, but look ahead. P for pay. Pay times 40 hours. But then, this is his overtime rate, 1.5 P, because he gets paid time and a half. So 1.5 times P for every amount or every hour over 40. How many hours over 40 did he work? Do I put the 60 here? No. He's only getting paid in time and a half for the extra 20. Your job, solve that equation, find out his hourly rate, and you have 1.1e homework section. This is great practice for your test tomorrow. That's it for today. Thanks for watching.